Imagine an object that notifies another object that something has happened. This is a common occurrence in game development, however, it's not an entirely trivial problem. Let's make it concrete. Say we have a game manager that notifies the player that the next turn has started. The naive solution to this problem is to hold a reference to the player within the game manager and then call the method directly. It may be acceptable for the game manager to know about the player, but it probably shouldn't know about all of these objects. They also want to know when the next turn has started. We could invert the dependency so that the individual objects hold a reference to the game manager, but the game manager does not know about any of the individual objects. I think this is a better solution, but it's still far from perfect. For instance, if the game manager is destroyed, everything breaks. Let's look at another flaw of this architecture. Suppose we want to call the method enemy spawned. We have three different spawners: single, wave and random spawn. And we have multiple different objects that can call the spawn method. This creates a cobweb of dependencies, and it's at this point where we usually introduce a manager to reduce the couplings. Now you can imagine that there are many of these situations when developing a game. We therefore end up with many managers and many objects that depend on these managers. This manager pattern makes prototyping and testing subsets of the game hard, if not impossible. If we want to test something without a manager, the objects depending on that manager breaks. So that's not optimal. Let's start from scratch and see if we can find a better solution. The setup is one object sending a signal to another object. To avoid dependencies, the sender should ideally not know about the receiver, and the receiver should not know about the sender. We can accomplish this by introducing a middleman that both receiver and sender know about, but they do not know about each other. This sounds a lot like the manager setup we had before, but this time the middleman is static. This means that there are no instances that can be missing and break things. And in the manager setup, we would create a new manager that was specific to the problem every time we ran into the problem of too many dependencies. With this solution, the same middleman is used for all cases. This middleman is what is known as an event bus. It receives events and forwards them to the listeners that are subscribed to that event. Let's see how this can be used in code. In our listener class, we can subscribe to an event by calling the register method on the event bus. This register method takes the listener as argument as well as the event identifier that the class wants to listen to. Lastly, the method that we want to run when the event is triggered is also defined as an argument. To raise the event, we call eventBus.raise, which takes the same event identifier as argument. I also pass in the caller so that I can debug which object raised the event. Sometimes I also want to pass data along with the event, and I can do this by adding an extra argument with the data. The register method still works even though data is sent with the event and we don't do anything with the data. But we can also register using the generic overload, and then the data will be passed to the method. I try to be engine agnostic and talk about concepts instead of implementations. But for my Unity people, I've linked the source code for the event bus down in the description. In this implementation, disabled Unity objects are automatically skipped when an event is raised. And this means that you can register in start, and then you don't have to manually unregister the object on disable. I use this event system in my games, and it's important not to lose track of what's happening with all these events being raised. Therefore, I have an overview of all the events that are being raised, along with the information about where the event was raised and what data was sent with the event. All of the core logic in this game is based around events, so to gain an overview over the game structure, you can actually just play the game and look at the events that have been raised. In conclusion, the event-based architecture is a powerful way to decouple objects, and I find that it reduces cascades of errors where you change one thing in the codebase and it breaks things in other places. Thank you for watching, subscribe, and I will catch you later.